Welcome to the Walton Pi. Today I'm going to go through an example of how test questions are graded so that you have an idea of what sort of effort you need to put into test questions to be able to get full credit on those types of questions. So today I'm going to go through 3 examples of how I have seen students respond to a question like this. I'm going to go through a rubric that I created for this question, and I'm going to go through and show how I would grade this type of question. Now, if this is helpful, please consider subscribing. It really helps me out and would signify that this is the type of video that I should probably make a few more of. Okay, so for this problem, all of the students are asked to use theorems from calculus and then show that there is a solution to 7 to the x minus 1 plus 4x is equal to 7 minus cosine x. So here is the first response. So take a moment and try and figure out how would you grade this question. So the way I would grade it is I would go through and try and figure out what are all the different pieces that they've done. So did they identify and use the intermediate value theorem? I don't see any evidence that they did that, so they would not get that first point. Next, did they rewrite the expression into an equation or find some other way of trying to solve it? Well, they graphed it, and they did a decent job at graphing what the functions are. But just graphing the functions is not enough to prove that there is a solution. So this is also not quite enough effort there. Next one, find a point where something's bigger than 0 and something smaller than 0. Again, not quite there, so they would not get this point. Now state that f of x is continuous on a sufficient interval. Well, the way that they've graphed this shows that it's continuous, so I would probably give them this point, as well as not having any algebra errors. So this would get a 2 out of 5. They were able to show it was stuff was continuous on a big enough interval. They just did not recognize that they needed to use the intermediate value theorem. Now, they didn't quite state that f of x was continuous, so if I was feeling pretty generous, I would give them the full 2 points. Otherwise, I might give them a 1.5 out of 5 because they knew that it was continuous in the way that they were graphing it, and I can tell that they knew it was continuous, but they never actually specifically stated it. So this one would get either a 1.5 or a 2 out of 5, depending on if it was just me grading the test, in which case I would be able to have my own discretion as to how I would award points, or if there's a group of faculty all grading it together, such as on a common exam for classes that are fairly large, then they might have to all have an agreement as to what would be accepted or not, and they might have to be stricter or more generous depending on how they're going through and doing it. So this first question would get a 2 out of 5 if I was the one grading it. Okay, the next one, let's look at this one. Okay, so for this one, again, using theorems from calculus, show that there is a solution to 7 to the x minus 1 plus 4x equals 7 minus cosine x. Go ahead, take a moment, and with the knowledge you've learned from the last one, see how would you grade this problem. Okay, so this one, first off, they're not identifying and specifically using the intermediate value theorem. They're using the same ideas, but they're not quite using the intermediate value theorem. So they would not get credit for that one. Now, they did combine them into expressions and then find points where they're bigger, so I would probably give them this point, but they did not state that f of x was continuous on the interval, so they would not get that. There aren't any algebra errors, and now I'm back to this one, rewrite the expression into an equation. Well, they took 2 different functions and got them to have different functions and stuff, but they're not quite changing it into an equation. But they are definitely a lot closer to it. So I'm thinking that this would probably get credit for rewriting that, but they didn't use the intermediate value theorem or use the fact that f was continuous. So this one I would give a 3 out of 5. It's not quite there, it's not doing enough to be able to get there, but they'd probably get a 3 out of 5. Now, the other thing, the intermediate value theorem actually does not apply in the case that they were doing it, because here they're saying that oh, f of 0 goes from 1/7, f of pi is 12, so that means f is doing something like that, but then g is doing something like that. So they're saying, oh, it has to cross somewhere in between there, because on this, at 0, f is smaller than g, but here at pi, f is bigger than g, so they had to have crossed somewhere. That's not what the intermediate value theorem says. The intermediate value theorem only tells us if we have a single function and how that's going to relate. So this one, probably 3 out of 5, maybe a 2.5 out of 5, depending on how the other faculty were requiring us to grade this type of problem. Because if it's a lot of people grading, we set a common rubric and then we all have to grade according to that rubric, regardless of how we might feel someone might have earned a little bit extra, depending on different pieces. Now let's look at this last example. Okay, so using theorems from calculus, show that there is a solution to 7 to the x minus 1 plus 4x equals 7 minus cosine x. Okay, well, let's go through piece by piece. Oh, right here they're saying by the intermediate value theorem, so let's first see they've correctly identified it. Now are they using it correctly? Okay, they have an interval from 0 to pi, and that's because those are the points they plugged in, so we actually can check off that they have found a point where our function is bigger than 0, and a point where the function is smaller than 0. They successfully rewrote the expression into an equation, and they know that we are trying to solve for where it's equal to 0, so they get that point. There's no algebra errors here. They are using the intermediate value theorem, but they forgot this. They did not state that f of x was continuous. In order to use the intermediate value theorem, we need f of x must be continuous. And so because it is not stated that it's continuous, I can't guarantee that. So as close as they were, this problem is getting 4 out of 5. It is very close, but they did not state that f was continuous, and therefore they did not completely finish the problem. They did not satisfy all the conditions that are needed in order to use the intermediate value theorem. Now, I hope this type of video is helpful in understanding how tests are graded, and hopefully this will help you on your own tests, that you can be able to avoid these sort of mistakes that would dock you points even if you clearly knew what was going on. Like this person, they knew what f of x, why it was continuous and stuff, they just never stated it. And because of that, we don't know what you're thinking, we can only grade what you wrote down. So be sure to write down all the different pieces of information that you would need for a different problem.